Okay, today we are going to learn about the first type of problem, that is normal type of problems in projection of planes. Okay, so for that we have the first question. You see the question: an equilateral triangular lamina of 25 mm side. That means we need to construct a triangle that will be that is having same dimension with respect to all the sides. So with one of its edges on HP. Okay, so here in this question we will be splitting that with respect to each of the positions. So it is telling that we need to construct a triangle of dimension 25 and it is resting on the HP plane with respect to the edge. Okay, we know how to construct a triangle with respect to the edge, right? We know the first position. Okay, so in the first position it is lying on the HP plane and it is starting with the edge. Okay, now you see, proceed with the question, such that the surface of the lamina is inclined to HP at 60 degree. You can see that. So herein the surface of the lamina, it is inclined to the HP by 60 degree. Okay, that's what the first inclination to HP. Now the same edge on which it is rest, okay, the same edge on which it is rest is inclined to VP at 60 degree. That is, you can see that the same edge which has been inclined in the HP, to that edge we are inclining again to the VP by 60 degree. So that's what the condition for normal type of problem, right? If the angle of inclination, if it is there with the edge and the same edge has been inclined both with respect to HP and VP, we calling that as a normal type of problems. Okay, so now we will proceed with the first position. You can see that we need to construct an equilateral triangle of dimension 25 with the side with one of its edges on HP. Okay, so I'm going to proceed with the solution. So if I am showing the solution here, you can see that. So we have to proceed. So I'll be drawing the first position. We know how to construct the first position, right? First I'm drawing an XY line, because in this projection of planes we are going to use only the first quadrant. Okay, remember it. So in the projection of planes we are using only the first quadrant. We are not using the second, third and fourth quadrant. We are using only the first quadrant. Okay, so we are restricting our problems from projection of planes only to the first quadrant. That's why VPHP. Okay, so now you see the question. Our equilateral triangle of lamina 25 mm is resting on the HP with respect to the edge. We know how to construct a triangle with respect to edge. Okay, so the dimension here 25. So I'll be measuring 2.5 box, that is 25 mm. Okay, I'll be showing the dimensions on one side. So this is 25. Now using the compass we know how to construct a triangle. Okay, I'm going to measure the same 25 mm dimension. Okay, I'm going to cut the arc from these two positions, from keeping at this point. Okay, cutting the arc. Okay, after cutting the arc, so you can join here. Okay, so this is what the first position, right? So equilateral triangle of dimension 25 resting on the HP plane. So this is what the top, you can see this. We know that the top view it is drawn in the HP plane. So we are writing the notations here. Small notation for a triangle, that is small a, small b, small c. So this is what the top view, correct? This is what the top view. Now we have to draw a front view of it. Say, so we have been placed like this, right? We have been placed the triangle like this, just in order for you to understand the first position, right? We have to draw the first position, top view and front view. So we know that front view will be lying in the VP plane. So in this top view we know that, so we have got the triangle of dimension 25. So if you are looking from the front view, okay, so if you are looking this triangle from the front view, you can able to see only this edge, that is BC. Okay, you are only able to see, if you are seeing from the front view, okay, from the front view you are able to see only this edge BC, correct? Only BC. So what we do to project the front view, so we will be using the projection line here. With the help of projection line, so projection line will be thin line here. Okay, projection line will be thin line, and then the V we will get it on this xy line here. So remember it. So the v which we get will be on the xy line. So now you see we are able to see the end BC, right? So I will be writing B dash C dash, which is visible. But you see, when you are looking from this front view, we are able to see this edge. We are not able to see this corner point. So this A dash will be in the brackets. Okay, this is what the first position. When we construct a triangle, we get the same dimension of 25. So when we project the front view, we are able to see only this edge BC. That's why B dash C dash is written without brackets, and A dash, A which is not visible, that is written within bracket. Okay, so this is what the first position. Now you see the question, such that the surface of the lamina is inclined to HP at 60 degree. So what we have to do here is, in the second position, we have to incline this. Okay, we have to incline it with respect to this HP plane by 60 degree. So when we are inclining this in the second position like this, so we are inclining this the edge B dash C dash. Okay, so this is what the length B dash C dash will be inclined here. Okay, so when we inclining it in the second position like this, so we are inclining this B C end only. Okay, so what I am doing is, so in the front view I am going to incline this line by 60 degree. So that's what we can see in the front view. Okay, I'm going to show the first front view, then I will draw the inclined top view. Okay, for that purpose, first I will be writing this B dash and A dash. This is our reference point. After that I'll be measuring this length. Okay, that is B dash C dash. I'm measuring this length. Okay, so this length I'm measuring it and cutting the arc. Okay, cutting the arc. Okay, cutting the arc. Now we have been already cutted the arc, but we know that we have to incline this B dash C dash by an angle of 60 degree. Okay, by an angle of 60 degree. So what we do here is, so with respect to this point, this B point exactly to this B dash point with the XY line. So I'm fixing this protector and marking for 60 degree. Okay, marking the 60 degree, marking a 60 degree. Now you see that I'll be drawing a straight line here. I'll be drawing a straight line here. Okay, so this is where we got. Now again what I'll do, so I'll be measuring this length, such as B dash C dash. I'll be extending this arc. Okay, extending this arc which I have, that is B dash C dash. So it is been the angle we got here, it is 60 degree. Okay, so after getting this length we will rub it. So this is what the actual length we require here. Okay, till here. So I am going to dark that. Okay, I'm going to dark this length. So this is the length we actually require. Okay, so now, so we have to draw the inclined top view. Say this is inclined at 60 degree like this, so we have to draw the top view of it. How we do that? Using the projection principle. You just follow the procedure, you will understand. So projecting the lines here, projecting the lines downward. Okay, so from both front view and top view on either side, we can able to construct the second position inclined view. Okay, second position inclined top view. Okay, so we have been projected the lines. Now we have to see where the points are made. A dash, from there is a projection line, and A, these two are merging at this point. This is our A point. Similarly B dash and B, it is merging exactly here. This is B. Now similarly C and C dash, this it is merging here. So now we can join this to construct the inclined second position top view. So now we have done with the inclined second position top view. Now we see the question, the edge on which it rests is inclined to VP at 60 degree. That is, we know that it is like this, it is inclined. Now we have to incline the same edge. We have to incline the same edge. What we do? We are going to incline with respect to VP like this. Okay, we will be inclining like this. So for inclining that, first initially we are going to draw an angle line here. Okay, we are drawing an angle line. Okay, for how much it is 60 degree. So we are drawing for an angle line of 60 degree. Okay, so initially you mark a point here. To that point, okay, to that point you initially mark a point on XY line, then again after that you can mark a point, so that will be easy. First you mark a reference point, then keep the protector, and then you mark a point. Now this is what our angle line, okay, 60 degree angle line. Okay, so this is 60 degree. So now what we do, we are taking this BC edge like this. So this is what our resting edge, right? AB, sorry, AB, this is a resting edge. We'll take this AB resting edge and we are going to place it like this on the angle line. This is how we can make the triangle inclined to HP. Now it is inclined to the VP. Okay, so you follow the first time you mark a point of A, reference point A. Now we'll be measuring this length AB. So transferring the inclined view here. So inclined top view, okay, not the first position. We have to project the second. AB, I have measured the length. So take this AB length and you can cut the arc. Okay, so cut the arc. So this is what our AB. So now we got the length AB. Now we have to cut. We have to transfer this diagram on this angle line. So from A to C, first arc. A to C, first arc you have to cut. Okay, then second arc from B to C, it is somewhat same, the arc length you will get. Okay, so this point is C. Okay, so now you join it. Now we join this. Now join this. This is what your inclined third position, top view. Now in order to draw the final position, what we do, we are going to project it upwards using the projection lines. Okay, with the help of projection lines from the side, we are going to draw the final view. Now you see where these two are merging from the top and front view, A and A dash. A dash also here. So these 2 points are merging exactly here. This is our A dash. Similarly B and B dash. So it is merging on the same XY line. So this is B dash. Similarly now C and C dash. These two are merging here, C dash. Now we are going to join these views. Okay, AB we have joined. Now from A to C dash and B to C dash. So we have drawn. You see that. So these views need to be darker. Okay, darker, thick lines. So this has to be drawn with thick lines, and projection line has to be thin lines. Okay, projection lines has to be thin lines, and this has to be thick lines. Okay, actual views. So now you understood, right? So it is like this. So the problem proceed. First position, we have drawn a top view and the front view. In the top view we get the same dimensions, and in the front view we are able to see only this B, C. That's why B dash, C dash visible, A dash will be in bracket. Now in the second position we have inclined like this. That is, we are inclining the B dash, C dash line in the front view by an angle of 60 degree. So that's why we did this one. Then after that we did this position. Now in the third position what we did, so we have to incline this lamina by an angle of 60 degree. So for that purpose, first we have mark and reference point, then we use the protractor, mark for 60 degree, and then we draw an angle line. Then after that we mark a reference point A. Next after that we from the compass measured the length of AB and cut the arc. Then again for arc from A to C and B to C. We have completed the diagram. So this diagram we have used for copying here. Then using the projection lines we have been mark the final view. So how the problem proceeds means, so this is our first view, second view, third, this is fourth, this is fifth, and this is sixth. Okay, so this is how we do the normal type of problems in equilateral triangle. Now the same problem we are going to construct in the SolidEdge software to construct a triangle here. So before that you mention VPHP X5. For this you will get 2 marks. To construct the triangle, go to polygon by center, give the number of sides as 3. Now place the lamina with respect to edge on the left hand side reference, and select the edge and give the dimension 25. So now it has been, we have drawn a triangle of dimension 25. Now change the thickness to 0.50 mm. Okay, now write the namings of it. CABC. Okay, draw the projection lines upward to complete the front weave. So projection line thickness has to be 0.13 mm. Okay, the front weave, mention it with 0.5 mm thickness. Write the namings of it. It is B dash and C dash visible, but A dash not visible. So A dash should be mentioned within brackets. Okay, A dash should be mentioned within bracket. Now select the front weave. Go to move command. Creates a copy of it. Slide along the XY line. Okay. Now go to rotate. Okay, select the one end. So before doing it, unselect the move copy, because it will create many number of copies. Okay, so better before rotating it, you unselect the create copy. Okay, unselect it, select the one end and the other end. Now rotate and give the angle 60 degree. Okay, now find out the angle using angle between command. Select the line and XY line, click on the fit, draw the projection lines downward. So guys, in this particular video you are getting both how to do in sketching and both in software. So this is a very helpful video. You can subscribe to this particular channel and share to your friends and classmates so that they can be benefited. Okay, this is the only paper you are having external examination. Okay, and the subject will become easy if you follow step by step, and you can able to score 100 out of 100 in this. Okay, so make sure you select like this. Okay, the cross mark you should appear, intersection mark. Okay, the second position top view it is completed. Now the third position, so we need to draw an angle line. So give the angle in negatives. Okay, here in the angle you can type minus 60 degree. Okay, and find out the angle here using angle between command 60. Now select the second position top view, go to move command, creates a copy of it and select the end point A here. Okay, place it on the angle line. Now go to rotate command, select the end point A properly and end point B and place it on the angle line. Now draw the projection line upward to complete the front view. Guys, I have completed all the types of problems in this particular channel, whether it is related to module 1, 2, 3 and 4, and model question paper also solved, and the same problems have been completed in the software, SolidEdge software. SolidEdge 2024 student version also available in this particular channel. You can download and install in the Windows 10 and Windows 11 software operating system. Okay, so no need to go for any license version. The free version only I have uploaded in my channel. You can download it and easily install. Okay, so that it will be benefit for you. So if you find this particular video useful, subscribe to this channel and click on the like button, and if you find it is very useful, share to your friends and classmates. Thank you guys, thank you for watching the video. So this is how we complete the problem in the SolidEdge software. Thank you all.